Now the next layer is classification or fully connected layer. This is the final layer where the actual classification happens. Or you can say this is layer in which we are making our network for the MLP, input for the MLP. Okay, so you can see in the Excel sheet like what we are going to do here. We have this output from the pooling and we need to flatten this output. Like how to do it? We are making like 2D array to 1D array. First I'll take this item 1, then downside the second item 1 and then 0. This is the first row. I'm making a column. Then similarly for the second row also making a column. Okay, and similarly for the third row also making a column. So this is the flattening of the max pooling output. Okay, now I'll tell you like what will happen. This is output of one filter. Okay, and it's our choice. We can take lots of filters in the convolution. So here in this Excel sheet I have shown two filters. One is this one and another filter is this one. So we have taken two filters. So output would be 2 images. Max pooling output would be 2 images. So here we are stacking up the layers. So here we are getting multiple images from a single image. Right, and it depends on the number of filters. And you can see here in the convolution like this is till this the part of the convolution. Now we are going to convert into the MLP. So in the convolution we can say mainly 3 layers, and one is the convolution, then ReLU and then max pooling. So in the convolution I have taken 2 filters, then it is giving output of 2 images. And you can see we have taken image of 7 by 7 size in the convolution as an input, and now this image is converted to 3 by 3 image. So we have performed 3 operations: convolution, ReLU and pooling. Okay, so as output of one layer is output of convolution is input of ReLU, and output of ReLU is input to the max pooling. So you can say output of one layer is the input of other, and we can stack up these 3 layers. Like I can show you how to stacking up. We can take the image, input image just like this, then we perform the convolution, then the ReLU and then the pooling. And then we got an output like in this take an example. I got an output of 3 cross 3 image, and I got like it depends on the number of filters. Suppose I have taken 3 filters, then it will give you 3 images as output. Okay, and one more thing, like we can repeat this process. Like these are the 3 layers. Okay, and we can repeat these 3 layers as much we want. Like each time what happens, the image gets more filtered as it goes through the convolution layer and smaller as it goes through the pooling layer, right? So if we want to do the more filtration and the size reduce of the image, then we can repeat all these 3 steps. So what we can do, we can take an image just like here, and then we can perform these 3 operations and these 3 layers, and again we can implement these 3 layers, and it's up to you. You can take n times to perform these 3 layers. Okay, so finally we got an output just like this. Okay, now we need to convert this output as an input to fully connected layer, and fully connected layer is the final layer where the actual classification happens. Okay, here what we are going to do, I'll just show you one example. here like I have value 1 space 0 space 1 and then 2 space 0 space 1 and then I have value 3 space 1 space 2. This is the basically you can say the output of pooling layer. I need to convert this into the fully connected layer. In the fully connected layer, what I will do, I'll write the output into 1D array like 1 then 0, first row I'm taking first, this is first row 1 0 1, I'm keeping this 1 0 1 and then the second row 2 0 1 and then the third row 3 1 2. So this is the output of after the flattening. We have done the flattening of pooling output and this output can be input as a input to the multi-layer perceptron or you can say input to the fully connected layer. So what we have done, we have taken our filtered and shrinked image and then we put it into a single list. Okay, and this can be a more values like in the max pooling, if I am getting 3 output, then it will pool, it will flatten all 3 outputs. Okay, so in this we will continue like here we need to write the continue like these 9 elements, then below this the 9 elements and then below this 9 elements. You can see in my Excel sheet it is more perfectly you can take a view like this is the output of one pooling. We have done the flattening of this output and this is the output of the second pooling or like second filter and this is the flattening of this output. So final output is this one. Okay, and this is the output of flattening or we can say this is input layer for the multi-layer perceptron. Okay, so this is the input for the multi-layer perceptron or you can say for the fully connected neural network. Now what we will do, we will pass this input to multiple hidden layers like here we have made one hidden layer and then the final we will got a output. Suppose we are classifying into the dog, cat and bird. So the output layer should represent the 3 classes bird, dog and cat. Okay, so till now like after passing to the hidden layers our neural network will be built and we are ready with a classifier or with a model. Now we will do the prediction part. Okay. Now come to our blog and here like till the fully connected layer we know how to convert to the single vector. Okay, and this flattened layer works as input layer for the neural network, you know very well. Now suppose that wherever there is a high value represented dog, take a look to the picture given below. Like this is a output. Suppose in this output like first, fourth and sixth and ninth, the values in these rows if have high value then we can classify this image as a dog. Suppose we are taking a patterns like this. And similarly for the cat we are assuming like the second, fifth and seventh values are high, then we classify a image as a cat. Okay, so these are the certain features for the dog image and for the cat image. Okay, so we have trained our model with these probabilities and now let's predict that it is a dog or a cat in a new image. So this is a new image we have taken. We have passed this image through convolution and passed it through the ReLU function and then did the pooling and then made a flattened layer the data. It looked like this, like final data, the image that is passed through the convolution can be output just like this. So in this image we will check the rows, like it have first row, fourth row, sixth row, okay, and ninth row. So you can see first row, in case of first row, fourth row, sixth row and ninth row, we are classifying as dog. So in case of first row, fourth row, sixth row, we can sum up the values and then we can divide total number of values. It will give you the probability of class, like 0.87. And we will when for the cat, we will sum second, fifth and seventh values, divide by 3, and we got the 0.5. So the classification score at the output we are getting for the dog 0.87 and for the cat we are getting 0.5. That means the probability of having dog image of this data of image is greater than the probability of cat. Means we can predict this image as a dog. Okay, so like this we can do the prediction. Okay, and in short I can summarize in the convolution neural network what we have done. Initially we have taken an input image, we have passed this through the convolution layer, and then in the convolution layer we have gone through each and every feature, and after the convolution we applied the ReLU activation to making the negative values to the positive, and then the third layer we perform the pooling to reduce the dimensionality size, and then we can repeat these 3 layers as many times as we want. Like if we are not satisfied with the output, then we can add more convolution layers, like these 3 layers, convolution, ReLU and pooling. And after that we will do the flattening the output and feed this into a fully connected layer. Okay, and then output, then our model would be prepared, and we will take a new image and we will do the prediction. Okay, so this is the basically convolutional neural network.